Hello students, in the previous video lecture we already discussed regarding larger memory structure as well as read-only memory. So in the present session I'll try to discuss about speed, size as well as cost following by mapping functions. An ideal memory should be fast, large as well as inexpensive. However, we can conclude that such a design is very difficult to implement because if you are considering one performance factor, that means if you want to achieve higher speed of operations with respect to the memory, obviously the size of the memory will be large. So that if you are considering the cost as a factor, such larger memory will be costlier. So for faster operations, SRAM chips can be used, but they are expensive since large number of cells cannot be packed into a single cell. So the size of the main memory, DRAM or SRAM, is still less compared to the type of the programming being run on the computer. So suppose if you are having larger size of the program which is to be executed within the system, so we cannot fit those set of programs within the main memory. Also we need to store large volume of data permanently, so hence we can go for secondary storage. So we are having in the diagram, we can observe that different memory units like registers, primary cache, secondary cache, main memory as well as secondary memory. So we are listed in the table like three different parameters like speed, size as well as cost. So if I am considering the register, I can say that the speed of the operation will be very high, but size is very small and cost wise is less cost. So similarly, if I am considering the primary cache, the speed will be high, the size which is smaller in size, cost is low. So if I am taking secondary cache, that is L2, speed is low, under size it is low, cost is also low. So if I am considering main memory lower than the secondary cache and the size is comparatively high while compared with the secondary cache once again, and cost is also high while compared with the secondary cache. So if I am considering secondary memory, so which is very large in size as well as which is costly, and the speed of operation is very low. Why? Because the size is large, it takes longer time in order to perform the read as well as write operations. So now in the second table we can have different characteristics. We are listed different characteristics like speed, size and cost. And if I am considering SRAM, the speed is very fast, size will be large and cost wise which is expensive. Similarly DRAM, which is slower, small and less expensive. Similarly if I am taking magnetic disk or secondary storage, much slower than DRAM, the size is small and the price will be low. So the diagram shows memory hierarchy which consisting of registers, memory cache, primary cache and secondary cache, main memory as well as magnetic disk or secondary storage. So all these types of memory units are used in a computer. The memory hierarchy including processor register to the magnetic disk storage is considered in the diagram. The processor register provides the fastest access. So if I am considering the speed, if I am considering the factor as speed, so I can say that the processor register provides the fastest access. The speed wise, the operation is very quick. SRAMs are used in cache to provide data to the processor at the faster rate. So next level, so if I am considering the other factor with respect to the register, processor register, that is cost. The cost wise, in order to store single bit of information within the register, so which is costly. So if I am considering register storage, So if I am considering the other factor as size, size wise the register size while compared with the secondary storage, which is very small. I can say that if I am considering register storage or register as memory unit, so that instant the speed of operation will be very high and cost is also high, but the size of the storage, that is register, is very small compared with the other level of memory units. So the next comes, within the processor, it consisting of two different cache levels. The first one is L1 cache and the second one is L2 cache. So level 1 and level 2 cache. So I can say that the SRAMs are used in cache to provide data to the processor at the faster rate. So I can say that in the main memory, which can be implemented using, I can consider either SIMMs as well as DIMMs format, so which is larger but slower than the cache memory, having access times 10 times as that of the cache. So if I am considering L1 primary cache level 1, so while compared with the processor register, the size is large, the speed of operation or memory operation with respect to primary cache is comparatively less than the processor register, but the increasing cost per bit storage, which is less compared with the processor register. Similarly, if I am considering the secondary cache or L2 level 2, so I can compare with respect to L1, the size of the secondary cache is comparatively large with respect to the primary cache, and the speed of operation is less compared to L1, as well as in order to store single bit of data or information, the cost is less compared with the primary cache. So next comes the main memory. So the main memory is associated with is located between the processor as well as the secondary storage. So in the case of main memory, which can be implemented using SIMMs as well as DIMMs, and which is lower compared with L2, L1 and register, and I can say that the size is larger while compared with L1, L2 and register, as well as in order to store a single bit of information, the cost wise which is cheap compared with L2, L1 and the processor registers. So the last level is magnetic disk or secondary memory. So in the case of secondary storage, which is very large and inexpensive, but which is very slow compared with the processor register, and size wise which is very large, and cost wise, in order to store single bit of information, the cost is less compared with the processor register. So I can say that with respect to the different parameters like size, speed as well as cost, so we can consider the different memory units like registers, primary cache or level 1, and secondary cache or level 2, main memory and magnetic disk and the secondary memory. So this in the case, however, they are the secondary storage, which is very slow, very slow compared to the semiconductor memories, I can say. During the program execution, the speed of operation can be improved by bringing the instructions and data as close to the processor as possible. So if you are storing the data or informations within the magnetic disk, so the execution time, it takes larger time in order to execute the program, so that such set of programs can be brought near to the processor and can execute the program. So next is cache memories. So in the case of cache memories, I can say that we are having one processor unit here and we are having one main memory unit here. So now what we are doing is, in the case of cache memory, some set of informations from the main memory will be copied into the cache. Some set of informations will be copied into the cache. Instead of the processor is accessing directly the main memory, the processor can access the informations from the cache. So that is how we can consider cache memory while executing any set of instructions. So the cache is located between processor and the main memory. So we know that the main memory, which is very slow compared to the speed of the processor. So that is why we are using a special type of memory which is called as cache memory or cache memory. So which is designed in order to reduce the time needed while accessing the information from the main memory. So here we are having two categories with respect to the cache. The first category is called as primary cache, which is called as primary cache or level 1, and the second one is called as secondary cache or level 2 The primary cache is always located on the processor chip itself, and the secondary cache, which is called as L2, and is placed between the processor and the main memory. So in the case of cache, we can make use of property called as locality of reference. We can consider locality of reference. Locality of reference. So in the case of cache mechanism, which is based on a property of computer programs called as locality of reference. Analysis of programs shown that the most of their execution times is spent on routines in which many instructions are executed repeatedly. So those many instructions are called as localized areas of the program. So within the program, some set of instructions are repeatedly executing mains. So those set of instruction areas is called as localized areas. So now we can say that by considering the localized areas of the program are executed repeatedly and the remainder of the program is relatively infrequently accessed. So this is referred to as locality of reference. So we are having in the case of cache, we are having two ways. One is temporal and the other one is spatial. In the case of temporal access, which means that recently referred memory locations is likely to be referred again. So we are having two ways. One is temporal. In the case of temporal, the recently used pages or referred memory locations will be less likely to be referred again. So in the case of spatial, which means that the memory locations in close proximity to a recently referred memory locations are likely to be referred soon. So that is, in the case of spatial, suppose if it is recently used, some set of pages are recently used, so those set of pages will not be referred in future. So that is called as spatial. So depending upon that, we are having two different algorithms. One is LRU algorithm and second one is MRU algorithm. So LRU in the sense less recently used algorithm, and MRU is nothing but most recently used algorithm. So the cache memory stores a reasonable number of blocks at a given time. This number of blocks is small compared to the total number of blocks available in the main memory. So that means we cannot fit all the informations whatever present or located within the main memory into the cache. So we cannot fit all the informations into the cache. So there is a link or connection between the main memory and the cache memory. So we have to map some set of pages from the main memory into the cache. So that is called as mapping functions. So the cache control hardware decides which block should be removed to create the space for the new block. So in the case of cache memory, suppose if I am considering one set of memory here. So if this is 100% full, the cache is 100% full. So at that instant what we have to do is, so we have to delete or we have to remove some set of pages or blocks or pages, and so that any new pages can be copied, new blocks or pages can be copied into the cache. So now for that we are using a function called as mapping function. So mapping function which decides which respective block need to be removed from the cache, so that within the cache we can create the new space for the new blocks. So that is nothing but mapping function. So in order to perform the mapping function, so we can make use of cache control hardware. So the cache control hardware which decides which block should be removed to create the space for the new block. The collection of rules for making this decision is called as replacement algorithm. So replacement algorithm which has some set of rules in order to decide which respective block need to be removed from the cache, and that algorithm is called as replacement algorithm. So in the case of replacement algorithm, what we are doing is, so we can copy some set of pages from the cache into the secondary storage or any other memory devices. So we can make use of some set of algorithms like most recently used algorithm or less recently used algorithm while deciding which particular block need to be removed from the cache. The cache control circuit determines whether the requested word currently exists in the cache or not. So suppose in order to perform read or write operation, whether the requested information is available within the cache or not. So we are having two protocols here. The first one is write through protocol. So in the case of write through protocol, here the cache location and the main memory locations are updated simultaneously. So here I'll consider processor, single processor. I'll consider the cache as well as I'll consider one main memory. So this is processor, cache, and this is main memory. So whenever any updations comes to the cache, processor will write the informations into the cache, or it will update the informations into the cache. So in the case of write through protocol, what happens is the cache locations as well as the main memory locations will be updated parallelly. So initially the processor will write the informations into the cache will write the informations into the main memory, and main memory will send an acknowledgement to the cache, and the cache will send an acknowledgement to the processor or host. I can say either host or the processor. So that is how we can write the informations with respect to write through protocol. But in the case of write back protocol, once again I will consider host or processor. So next is cache and the main memory. Here what happens is, Initially, the processor will write the informations, or the host will write the informations into the cache, and cache will send an acknowledgement to the processor. After sending an acknowledgement, the cache will update the informations into the main memory, and it will get an acknowledgement from the main memory. So this is how write back protocol works. In the case of write through protocol, which is simultaneously the informations will be updated on the cache as well as main memory location. But in the case of write back protocol, initially the processor or host will write the informations into the cache, and cache will send the informations into, it will send an acknowledgement to the processor. After that, it will update into the main memory. So that is how write back protocol works. During read operation, if the requested word currently not exist in the cache, then read miss will occur. So what is the meaning of read miss? The requested data is not available within the cache. So if it is not available within the cache, so such operation is called as read miss operation. So in order to overcome from this read miss, so load through early restart protocol is used. So in order to overcome from this, we can make use of load through or early restart protocol is used. In the case of load through or early protocol, load through or early restart protocol, what we are doing is the block of words that contains the requested word is copied from the memory into the cache. So before performing the read operation, the requested data word, whatever which is present or whatever which is requested by the processor or the host, so such block or the related block will be copied into the cache in advance, so that we can overcome from read miss operation. Also, what is the meaning of read miss? So during read operation, the requested word is not existing within the cache. In order to overcome from read miss, so we can make use of load through or early restart protocol. So in the case of load through or early restart protocol, the block of words that contains the requested word or requested information will be copied from the main memory or memory into the cache. So after entire block is loaded into the cache, then only the requested word is forwarded to the processor. So then only the requested word is forwarded to the processor. So this is how we can avoid read miss case in the case of cache. So next is during write operation. During write operation, if the requested word not exist in the cache, the requested word is not exist in the cache, then write miss will occur. So what is the meaning of write miss? The requested word is not exist in the cache. So if write through protocol is used, if you are using write through protocol, the information is written directly into the main memory. So in the case of write through protocol, the informations will be directly copied into the main memory. So that is how we can avoid write miss operation. So successfully the data will be or information will be copied into the cache as well as main memory. So if you are using write back protocol, then block containing the address word is first brought into the cache, and then desired word in the cache is overwritten with the new information. So if you are using, in order to overcome from write miss operation, if you are using write back protocol, then the block containing the address word will be copied into the cache, and in the cache we can update the information. So this is how we can avoid write miss in the case of cache operation.